Data management. Understanding data ownership, who can possess data, and who can publish books or articles about it are often complicated issues related to questions of project funding, affiliation, and the sources and forms of the research itself. For federally funded research, ownership of data involves at least three different entities: the sponsoring institution, the funding agency, and the principal investigator. The sponsoring institution. Most often, the sponsoring institution organization maintains ownership of a project's data as long as the PI is employed by that institution. The institution often controls all funding or the disbursement of government funding. Consequently, it is also responsible for ensuring that funded research is conducted responsibly and ethically. Within the sponsoring institution, a PI is granted stewardship over the project data. The PI may control the course and publication and copyright of any research, subject to the institutional review. The funding agency. Many research projects are funded by federal government agencies, philanthropic organizations, or private industries. These agencies often have specific stipulations for how data will be retained and disseminated. For example, they decide whether to publish the project's results or market a resulting product, rather than the PI. The PI and institution should understand his or her funding agency's regulations regarding a research project and the data it produces. The principal investigator. In addition to being the steward of a project's data, a PI may retain some ownership of the data. In academic institutions, PIs are sometimes allowed to take their research and its data with them if they change research institutions. Many universities have offices and policies in place to ensure that such a transfer of data respects both the rights of the researchers and those of the institution. The PI should develop and implement a communications plan at the project's outset. Whenever possible, the communications plan should be written down and distributed to all members of the research team. The communication plan should also address data collection issues. A system for monitoring and checking data collection should be defined well before data collection begins. The following questions should be addressed. How much data has been collected and by whom? Has the data been entered or transferred into an electronic format? Has the transferred data been double-checked against the original to ensure accuracy? For human subject data, have identifiers been stripped from each and every record? Best practice tips on research team communication. Create a flowchart that lists all members of the research team, their responsibilities, who they are accountable to, who they supervise, etc. Include this in the communication plan or post it in a common area. Develop a plan for reporting project progress, propose changes, and problems. An email or memo may suffice for some issues, while other issues may require a team meeting. Hold team meetings on a regular basis as well as one-on-one meeting with individual team members. These conversations provide an opportunity for members to provide feedback or bring up problems that they might not feel comfortable discussing in front of the whole team. Best practice tips on research team communication. Create a team calendar that contains important dates for your project, such as team meetings or deadlines for progress reports. In addition, choose a way to notify team members, perhaps via email or memorandum, when important dates are approaching. Clearly outline rights to data ownership, intellectual property, and publication when a project is collaborative or involves the efforts of several PIs and/or research directors. Specify how and when research data can be published so as to avoid confusion later on. Even if not required, consider establishing a structured system for communicating with the sponsored institution and the funding agency. This may entail making periodic phone calls or sending monthly progress reports to keep them informed about the status of the project. Data collection refers not only to what information is recorded and how it is recorded, but also to how a particular research project is designed. Although data collection methodology varies by project, the aim of successful data collection should always be to uphold the integrity of the project, the institution, and the researchers involved. Data collection may seem tedious or repetitive, but the data produced in research ultimately prove or disprove hypotheses and justify or counter a body of research. Enables those involved in the research to more accurately analyze and assess their work, allows independent researchers to replicate the process and evaluate results, impresses upon research team members the importance of data management, details the rationale behind a research project, yields reliable and valid results, and hypothesis testing. Collecting valid data. Collecting valid data ensures that when research is evaluated, it will be deemed good science, meaning that the research is both precise and honest. Thorough data collection should thus include a continuous system for rigorously evaluating effective or deficient elements in the project, protocol, or the research team techniques. Record keeping. When data is actually collected, the record should attempt to accurately represent the progress of a project and answer such questions as what, how, and why data are collected or amended. Records should be durable and accessible but safe from tampering or falsification. Include notes. Your record should allow you not only to account for what occurred during the course of research, but also to reconstruct and justify your findings. It is important that records include notes about what method did or did not work, observations, and commentary on the project's progress. Noting errors. Use a consistent system for noting errors or adjustments. In written records, make entries in indelible pen so that the records cannot be altered or damaged. If information needs to be changed or amended, mark through the entry with one solid line and initial and date the change. The records can thus reflect what has occurred during the course of the project. Recording information. Record anything that seems relevant to the project, its data, and the standards of the project. At a minimum, records should include the following information: date and time, names and roles of any team member who worked with the data, materials, instruments, and software used, identification numbers to indicate the subject and/or session, data from the experiment, and any pertinent observations from the data's collection. Data analysis is the way raw data is chosen, evaluated, and expressed as a meaningful content. The form of analysis should come from a particular project's function and needs. Additional consideration might include the research setting or the type of research. With few exceptions, guidelines and objectives for data analysis should be determined before a project begins. Data analysis is often delegated to a biostatistical service department or to a project statisticians. If an outside statistical service is hired to do the analysis, the PI should work with the agency to ensure that the agency understands and complies with that project's data management protocol. While some members of the research team will be minimally involved with data analysis, they should all understand the data analysis plan and be able to interpret the results within the context of the study. Responsible data analysis attempts to accurately represent what occurred as part of the study but does not overstate the data's importance. Data analysis becomes data manipulation when finding what you want takes precedence over representing what is in the data. Intentional falsification or fabrication of data or results include the following: foregoing, inventing some or all of the reported research data or reporting experiments never performed; cooking, retaining only those results that fit the hypothesis; trimming, the unreasonable smoothing of irregularities to make the data look more accurate and precise. Data storage is crucial to a research project for the following reasons. Properly storing data is a way to safeguard your research investment. Data may need to be accessed in the future to explain or augment subsequent research. Other researchers might wish to evaluate or use the results of your research. Stored data can establish precedents in the event that similar research is published. Storing data can protect research subjects and researchers in the event of legal allegations. In order to maintain the integrity of stored data, project data should be protected from physical damage as well as from tampering, loss, or theft. PI should decide which project members are authorized to access and manage the stored data. Notebooks or questionnaires should be kept together in a safe, secure location away from public access. Privacy and anonymity can be assured by replacing names and other information with encoded identifiers, with the encoded key kept in a different secure location. Ultimately, the best way to protect data may be to fully educate all members of the research team about data protection procedures. Electronic data can be protected by taking the following precautions. Protecting access to data. Use unique user IDs and passwords that cannot be easily guessed. Change passwords often to ensure that only current project members can access data. Provide access to data files through a centralized process. Evaluate and limit administrator access rights. Ensure that outside wireless devices cannot access your system network. Keep updated antivirus protection on every computer. Maintain up-to-date versions of all software and media storage devices. If your system is connected to the internet, use a firewall. If your system is connected to the internet, use intrusion detection software to monitor access. Data sharing usually occurs once a study has been completed. Data reporting includes discussion of the data. The data analysis and authorship of a project, especially in the context of a particular scientific field. Data sharing and reporting are typically accomplished by publishing results in a scientific journal or establishing a patent on a product. PI should be aware of the various guidelines and restrictions that may apply to the dissemination of their research. There are usually stipulations specific to the funding agency or sponsor's institution, describing when and how results should be shared. Data management needs and preference. After outlining the project needs regarding data collection, storage, protection, retention, etc., the PI should assign tasks related to each of these needs to the appropriate team member. Research team member skills. The PI should be familiar with each team member's skills so that the appropriate task can be assigned and/or training can be arranged when needed. Research team roles. The PI should clearly define each team member's responsibility for each aspect of the study so that the data's integrity is maintained at all times. Potential problems. At the start of the project, the PI should review other data management issues, such as those related to data ownership and sharing, to determine if they pose a concern. Timeline. After establishing an action plan for completing the project, the PI should write a detailed timeline to keep the entire team informed of important dates and deadlines.